All right, guys, we're going to work on some slightly different properties that we hadn't really talked about before. There's going to be two videos here. One's going to focus on the new geometry parts that we have to learn, and then I'm going to make a second video where we learn some of the new algebra that we have to know for today's lesson. So this is going to be just the geometry part. Here's some circle information. So first rule, if a diameter is perpendicular to a chord, it cuts the chord in half. The converse is also true. What that means is if you have a diameter, and I actually just drew a radius here, but isn't a radius just a piece of a diameter? If you are perpendicular to a chord, it's guaranteed to cut it in half. And the converse is also true. So if I gave you a circle and I drew a chord, and here's the center of the circle, and I go like this, and I tell you that the radius is that it cuts it in half, then you know that it must be perpendicular. So those rules go back and forth. If it's perpendicular, you know it's cut in half. If it's cut in half, you know it's perpendicular. Why is this so important? Well, if that's the case, you are just one radius away from having a right triangle. One radius away from a right triangle. So there's the first new rule. If a chord is cut in half, you know it's at a right angle. And if you know it's at a right angle, then you know it's cut in half. Second new rule, if two chords are the same distance from the center, then they are congruent. The converse is also true. We talked about this in class a little bit, but if you got yourself a circle, let's say this is the center of the circle, if you go directly through the center, it doesn't matter what direction you go, aren't they all the same size? The answer is yes. Well, what if you keep getting farther and farther away from the center? What keeps happening as you get farther and farther away from the center? They get smaller and smaller and smaller. Well, what if I drew another chord over here that was the same distance as the first one? So let's say, I know it didn't look perfect. Let's say it's like right here-ish. Like if this distance matches this distance, then those two chords would be the same size. That's what this theorem is stating. Now, how do we measure distance? We always measure distance the shortest possible distance. So when I say something's like 10 units from the center, I mean the shortest possible distance is 10 units. Not here, not here, not here. The shortest distance, which conveniently is always at a right angle. Same thing over here. It has to be at a right angle. That's how we measure the distance. So if those are both 10, what we're saying is that these two chords, if they're the same distance from the center, that they got to be the same size. And there's some other cool things. We just learned the property a second ago. If you're perpendicular and you're a part of a radius that you're going to cut it in half, that means all the little pieces are going to be the same. And you are also just one radius away from a right triangle. Okay. So let's practice using those properties. What would it actually look like? Find the area of the circle. That's the question. Well, we have a center. This is a piece of the diameter, right? If I drew the entire diameter, wouldn't it use that piece? So that's what I was talking about a second ago. So you don't have to have the whole diameter for it to be true, but this would be part of the diameter. We know that AB is 48. So the rule is if you are perpendicular to a chord and you are a part of a diameter, that you cut that chord in half. And since the whole thing's 48, that means each part must be 24. It says find the area. Well, area of a circle is pi times the radius squared. So I need the radius. Should I draw the radius right here and then cry, oh, what do I do? I don't know. Nope, that doesn't sound good to me. How about drawing the radius this direction? And now we have a right triangle with 10 and 24. So I would reduce those numbers, but if I'm working on Pythagorean theorem, I know it's 10 divided by 2 would be 5. 24 divided by 2 would be 12. I know it's a 5, 12, 13, so the radius is 26. So the area equals pi times 26 squared. I don't actually know 26 squared off the top of my head. I should, but it's 676 pi would be the radius, or be the area. So that's one use there. Here's another situation. They tell you that CD is 24 and the radius of the circle is 13. Well, should I draw the radius here and then be sad? Should I draw this radius even and be sad? Nope, those aren't helpful. The most helpful radius would be the one that meets the chord at the end. So the radius is 13. Could I draw a line that is perpendicular? Yep. And what do we know about lines that are perpendicular, or sorry, what do we know about diameters that are perpendicular to chords? They cut them in half. And that is a piece of the diameter. So if the entire chord CD is 24, each part must be 12. And then this would have to be 5. That's another 5, 12, 13. So 2, 5, 12, 13s in a row. How far is the center? How far from the center is the chord? It would clock in at 5 units. So just knowing that property was the key there. All right, here's another use. It says AC equals 24, BD equals 6. Find the diameter of the circle. AC is not a diameter. So, you know, archaeologists kind of do this, like when you are finding new things out in the wild, like you're not always going to get like a full item. So like, you know, old pottery and old plates and things like that, you know, you're going to find little pieces of it. So here's something you need to understand. Even if you find just a little part, right? Like let's say you find just a little section of the plate. If you draw a chord that connects the ends of the arch, you can figure out what the rest of the plate would look like, or at least how big it was. You measure the thickest part, right? That thickest part, here's what you need to understand. The thickest part must be part of that circle's diameter. So if you drew the rest of the circle, you would know that if that thickest part would have to go through the center of the circle. So every test and quiz we take, we're going to have a question like this where we have to do this. The steps are not going to change, just the numbers will. You need to be ready for this. So we're going to draw the rest of the circle. Whoop! And I was informed just today. I did a similar problem with my class, and when I tried to do that, I won't mention any names, but you know who you are. They said that was the ugliest circle they've ever seen, and less than a second later they said, "Oh, but it looks like you." So, okay, so I'll go cry about that later. But I don't think it's that ugly. Maybe I did it better this time. I don't know, but it's a circle. AC is 24. Here's the thing: if this is perpendicular at the middle like that, and it's cutting it in half, right? They said it. You know, they have it marked. Then you know it has to be part of the diameter. So I'm going to draw the rest of the diameter. So you're going to do this every time. This is on your quiz. This is on your test. You draw the rest of the circle. You draw the rest of the diameter. If AC is 24, because it's perpendicular, we know it's cut in half. BD is 6. We're going to call the rest of it X. Now the center might be something like this. So X is not the diameter. We know that X plus 6 equals the diameter in this case. It has to be that entire thing. But now it's properties that we did last time. It's going to be part, those are two chords. It's going to be part times part, 12 times 12 equals part times part, 6 times X. That's our setup. That's what we're going to solve. And if you remember, if we can, we divide first. I can divide both sides by 6. 12 divided by 6 is 2. And so we get 12 times 2. We get X equals 24. And so X equals 24, so the diameter equals 30. Find the diameter, we're done. So 30 is the answer on that one. Okay, we're going to try another one. Highly recommend you pause the video and try this on your own. It's the same premise. An arch is 12 feet tall and 30 feet wide. What is the radius of the entire circle? So I draw an arch. What are the things that they just told us? The arch is 12 feet tall. And when we measure height, we don't measure it over here. We don't measure it over here. It's going to be at the thickest part of the arch. So the thickest part is going to be 12. And since it's perpendicular, right, we measure height at right angles, we also know it's going to cut it in half, making you have 15 and 15. So this is the starting picture. We need to finish the job. The rest of the problem would be finish the rest of the circle. Beautiful circle. Finish the rest of the diameter. Call that X. And now we treat it like any chord question. It's going to be part times part, 12 times X equals 15 times 15. So we're going to divide both sides by 3 because we can. That's going to get me 4X. 15 divided by 3 is 5. 5 times 15 is 75. So we know x equals 75/4. We know that the diameter equals x plus 12. We know that the radius is going to be the diameter divided by 2. So let's focus on the diameter first. So x plus 12 would be 75/4 plus 12, which I would then do 12 times 4. That would be 48/4, right? 12 is the same thing as 48/4. So that'd be 110 plus 13. That'd be 123/4. So the radius is going to be half of that, which I would multiply by 1/2. That's going to be easier than dividing by 2 this time. That's going to be 123. Oh my goodness, 123 divided by 8. So the radius would be 123/8. But our starting premise is draw the rest of the circle. Part times part equals part times part. So those are the new properties we need to have. The big deal is if it's perpendicular and it goes through the middle, it cuts it in half. If it's perpendicular and it goes through the middle, it cuts it in half. If it's perpendicular and it goes through the middle, it cuts it in half. If it's perpendicular and it goes through the middle, it cuts it in half. If it's perpendicular and it goes through the middle, it cuts it in half. Love it. See you next time.